computer instructions. What are the various instructions that is going to help to perform the operation? Those are things we are going to discuss here. Okay. And already we have previous lectures available in the playlist. You can see that. And still you didn't subscribe, please subscribe our channel and share with your friends. So let's see the computer instruction. What are the various types of the instruction and how it is going to distinguish various modes as well as various operation. So let's see computer instruction. So finally here, what you see that basic computers, whatever discussion we are doing here, that is for the basic computers, not for the advanced supercomputer. Okay. So now in current scenario, it is different. Okay. This is the for the basic computers. So it has three instruction formats. So first one is the memory reference instruction. Second is the register reference instruction. Third one is input output instruction. So in case of memory reference instruction, so how these 16 bits are rearranged, what is their functions? So since it is the memory reference instruction, so that is this instruction is going to help us to communicate with the memory. So we have considered here with basic computers with the memory size of 4096 cross 16. So it has to the power 12 locations with each word capacity of 16 bits. So here 12 bits address is required. So that's why for the address 12 bits are given and 3 bits are given for the opcode. It is going to decide which type of the micro operation will be performed. So with the help of 3 bits, we'll have total 8 combinations. So that 8 different micro operation can be represented here. And this I, that is the 15th bit, is going to decide whether we have direct addressing mode or indirect addressing mode. So in case of direct addressing mode, this I value will be 0. In case of indirect addressing mode, I value will be 1. So already we have seen direct addressing modes. So this given address is going to give us the location of the operand directly, whereas in case of indirect address, this address is going to give the address of the operand. Address of the operand. Okay, so in the 2 level, we are going to reach the operand. So here, this opcode is going to this 3 bits combination is going to change from the 000 to 110. So total how many here? 7. Okay. So 7 combinations are available for which one? For the memory reference. Total 8 combination is possible with the help of 3 bits. Since to the power 3 is what here? 8 bits. So out of this 8, 7 is available for the memory reference. Next, we have register reference instruction. So in the register reference instruction, again, what you are seeing that 16 bits are there. So now here we have communication with the registers. So this 12 bits are given for the register operation. And here this 12, 13, 14 bit is fixed. That is the 111. That means it is the 7. And this 15 bit is also fixed. That is the I equal to 0. So when I equal to 0, it shows that it is the register reference instruction. If opcode is 111. Similarly, for the input output instruction, again, we are not going to communicate with the memory here. So for the 12 bits are given, first 12 bits are given for the input output operation. 12, 13, 14 bit is fixed. That is the 111. That is going to be 7. And 15 bit is the 1. So when 15 bit is 1, it shows that it is the input output instruction when if opcode is the 111. So in case of memory reference, this opcode will have 000 to 110. Whereas in case of register and input output instruction, this opcode is the 111. But if 15 bit is 0, it is the register reference. If 15 bit is 1, then it is input output instruction. So here, if you have 0 to 11 bits, so that is total 12 bits, is going to check the operation, or if some operation is not being performed, so that in that case, it is used to test for the testing purpose, or which test to be executed. Like this initial 12 bits are being utilized. So now here we have basic computer instruction. What are the different basic computer instruction here? So this here what we'll have, you have seen that in case of memory reference, in case of register reference, and in case of input output, how this instruction codes having different parts. So finally, what we are going to see, in case of memory reference, what we are seeing, total combination is 0, 0 to 0, that is 110. Okay, that is the total 7 combinations are available here. So that's why, so the 7 combination is represented in the decimal from 0 to 6. So you see that here I equal to 0 means I equal to 0, it shows the direct addressing modes. I equal to 1, it shows the indirect addressing modes. So here hexadecimal code is used. So each bit combination here having 4 bits. Like this 0 is 40. Similarly, 1x having 4 bits here. Like this, we have total 16 bits are here. But in the hexadecimal, we can we can save the space, and we can represent here with the help of 4 combinations. So that's why you are seeing that we have total 0 to 6 combination in case of direct addressing modes. So that MSB bits are 0, 1, 2, 3, 4, 5, 6. So here when this combination is available, is perform the, that is the opcode is for the AND. Then we have addition, LDA, STA, BUN, BSA, ISSA. So AND is means it's going to perform the logic AND operation, okay, and memory with the contents of the accumulators, and add is the addition, arithmetic addition, memory word to accumulators. LDA is the load memory word to AC. STA is the stored contents of the accumulator in memory. BUN is the branch unconditionally. And BSA is the branch and save return address. That our discussion will come later about branch, subroutine, and all these things. ISZ is the increment and skip if 0. Whereas in case of indirect addressing mode, when we have I equal to 1, then we have another combinations. So that is the here 8, 9, and this hexadecimal 10 is written as the A, 11 as the B, 12 C, 13 D, E as the 14. So that's MSP bits are in this format. Now this remaining 3 bits will have different combinations. Whereas in case of register instruction, what we are seeing that last opcode having combination of 111, that is the fixed, and 15 bit is what, 0. So finally here 0, 1, 1, this combination in the what, it is the 7. So that's why all MSB bits are what here, 7 in case of register reference instruction. So CLA clear the accumulator, CLE clear E, again CMA complement accumulators, CME complement E. So C that is the circular right shift, CIR circular right accumulator and E, CIL circular left shift of AC and E, INC is the increment, SPA is the skip next instruction if accumulator contents is positive, SNA is the skip next instruction if accumulator is negative, SZ is the skip next instruction if accumulator contents is the 0. So here P is for the positive and for negative, Z for the 0. Next we have SZE, skip instruction if E is 0. So here last was the A, so means we are talking about the accumulators. Here last is E, so we are talking about the E register. HLT for the hot computers. If you are going to read somewhere microprocessor and microcontroller, so there you'll understand the importance of the instruction, how you can write the programs that machine is going to understand. And for that, we have different opcodes are there. So that you are going to study in microprocessor much detail. Next, we have input-output instruction. So what we have seen, we have this opcode combination is 3, 1 and 15 bit is also 1. So this combination of 4, 15 is what here? This 4 combination of this 4 is what? 15. And in case of hexadecimal, 15 is written as F. So here all MSB bits are what here? F. Okay. And remaining these last 3 bits are going to change. So INP is the input character to accumulators, output character from accumulators, SKI skip on input flags. So we have different types of flags. SKO skip on output flag, IO and interrupt on, IOF interrupt off. So later we'll have different flags. Okay, carry flags, auxiliary flags, zero flags, all these parity flags. These are the different flags are going to come later stage. And those things are important in memory in case of microcontroller and microprocessor also. So finally here, if you summarize this, so this we have various instruction types, so that computer should have set of instruction. So this instruction purpose is that how these users can going to communicate with the machines, okay, and can evaluate the particular function which can be computable by the machine. So each and every machine have some limitation. Like suppose if you talk about basic computers, so they're having some limitations. All scientific operation cannot be performed by the basic computers. So that's why we have scientific computers or supercomputers that has been used for the satellite communication, satellite launching, and for the space communication. So here, whatever system having capability, that user can interact with the help of set of instructions that machine is going to understand. After that, machine will perform the operations. So like if you're writing the program, high level program means we are going to use the compiler that converts your whatever program we are writing into the machine language. So machine is going to understand and that perform the task. Next, we have functional instruction. So this functional instructions, whatever things we have, arithmetic, logic, and shift instructions, those are like ADD, CMA, INC, CIR, CIL, and CLA. That are all things we have seen here. Okay, functional instruction. So this is complement of accumulator, increment, circular right, left, hand operation, clear accumulators, addition. Next, we have transfer instruction. So this here transfer of the data takes place between two contents. So this transfer may be between the main memory and the processor registers, or sometimes between the registers, so register also. So LDA is going to load the accumulator, STA is going to store, okay, the information. And next we have control instruction. So control instruction, this is the for the program sequencing and control, like sometimes a branch is going to occur. So how it can perform the branch instruction on the basis of priority level, which having higher priority on the basis of that particular instruction will be performed. Again, it will back to the previous sequence which was being executed. So we have branch unconditional instruction here. And again, BSA and ISZ, that is Z for the 0. Next, we have that is about the flag and all these things. Conditions are going to also come. Next, we have input output instruction. So this input output instruction is going to perform. So input output. So that is INP and out. So like this, we have 3 different instructions and we have 3 different types of the instruction: memory, reference instruction we have seen, and apart from this, we have register, then input outputs. So these are the discussion about various computer instructions and how it is going to work and how it has different notifications. So what we have seen in case of memory, opcode is going to change from the 0 to 6. In case of register and input output, opcode is fixed, that is triple 1. In case of memory reference, 5th bit is can be 0, can be 1. On the basis of that, you are going to see it is direct or indirect. In case of register reference, 15th bit is compulsory 0 and opcode is triple 1. In case of input output, 15th bit is 1 and opcode is 111. Like this, we are going to see how which type of the instruction we are using. Okay, thank you very much.